In the last lesson, we learned about hydrophilicity and hydrophobicity, and how soap, a detergent, can bridge between both worlds. We learned that lipids are amphipathic molecules that assemble to form cell membranes. All cells are surrounded by lipid membranes, even bacteria. I wonder how soap affects bacteria. You know what? Let's see and find out. Hi, so welcome to my lab. The question was, how does soap affect bacteria? So in order to test that, all we really need to do now is get some live bacteria. Oh, Iran, perfect. Put them over there. Is everything okay? Great. So at this point, all we have to do is set up the class. Michael, come on, help me set up the class. Hi, so welcome to the mini class. Today we're going to discuss and examine how bacteria are affected by detergent. And so for this, Michael, please take some of the bacteria and add equal amounts to 2 test tubes. Good. So to 1 test tube, add some buffer and label the test tube C for control. Controls are necessary in all experiments, and it is those controls that we compare to with the experimental. In this case, the control is just buffer, and we're going to see that buffer, in essence, doesn't do much to bacteria at all. Mark it C for control. And so now we take this tube. In the second tube, add the same amount, but detergent. And we'll be able to see how the detergent affects the bacteria. Once again, we're going to use the projector. And we're going to place some of the control bacteria into the Petri dish, as you can see here. And a little wiggling and twirling, we can see the bacteria cover the total surface of the plate. And as you can see, it gives sort of a golden brown, turbid transmission. And what we would like to do is compare it to those bacteria that were affected by the detergent. Now please give me the experimental. Here it is, experimental. And we're going to pour that into the second Petri dish. Now what do we notice? In essence, what we see is that the control is turbid, it's dark, and the experimental has cleared. This is an interesting phenomenon. It's a phenomenon in physics in which the light coming through the projector is deflected by the bacteria. And each bacterium acts as an individual particle and deflects the light in a different direction. So the total amount of light that reaches the lens is less. However, detergent has in fact dissolved the bacteria. And the bacteria no longer act as individual particles. The light coming through the dissolved bacteria has greater intensity, and we can see that it is cleared. As you can see, the control bacteria flow evenly and give us a rather easy-flowing, uniform solution. Let's see what happens with the bacteria.
Looks like snot.
Very good, Jake. Actually, it does look like snot, but snot isn't the scientific term. It's viscous or mucoid. It looks like mucus. And that's indicative of the fact that by breaking open the bacteria, something has been released into the general solution. And what do you think that is?
Maybe it's cytoplasm.
Cytoplasm. Well, cytoplasm maybe, but obviously a very large molecule, very hydrophilic, and in some fashion interacting with the water around. And this is what makes viscosity. Now, if we propose a hypothesis and say that if it's now in solution in a hydrophilic milieu, in an environment, if we make that environment a little more hydrophobic, maybe this mysterious material will crash out. Do you have by any chance some alcohol?
Yeah.
Okay, good. So let's take some alcohol and add the alcohol to the dissolved bacteria. Here you can see that the solution has become a bit stringy, to say the least. Maybe let's take a Pasteur pipette and see if we can actually lift whatever it is inside. And as you can see, it tends to be stringy and mucoid and viscous. What do you think this material is? This is DNA, the material of life.